concept called as Java collections framework. The most important concept coming to the development environments, right? Collections framework. Collection. So what is this collection framework and where it is used and how it is used, right? We will try to learn, right? The mostly used framework coming to the development of Java based applications. Right? Voice is not clear. Okay. Is it really not clear? Is it okay now? Are you facing a right? So we are going to discuss the most important framework, which is hugely used in developing the Java-based applications. That is collections framework, right? Collection framework, or we call it as Java Data Util package. So this framework is shifted as a one package. That package is called as Java.util, right? Dot star or something. Star means classes of that package, right? So this is a package which is shifted like this. So we have this Java.util package, or we call it as collections framework. So what exactly it means? What is the meaning of collections framework? What it contains? What is this package is given for? Why this package is given for? So what is the importance of this package and all we try to understand first of all, right? So whenever you develop the applications, whenever we develop any sort of applications, any kind of project, you will come across some kind of common logics. Very common logics will be there in almost all applications. Right? If you take the web application, you will find some kind of common logics for developing user interfaces, for writing your business logics and the database codes, validations. Right? Like this, you will find lots of common logics. So everywhere, whenever you develop the applications, you will find some kind of common logics. And if your application is having data, like a data application is having, like, means what is the meaning of having data means? So whenever you want to take the data, process the data, and store the data, and if you want to use the data for later period of times and all, that is what generally we are going to do here. Let's suppose if I take a banking kind of applications. Now I'm going to take the details of a customer. I'm going to register this customer details into my database. Like this, you are going to do. Right? Then you are going to maintain the customer details in the databases and transaction details and all lots of things we are going to do here. Right? So let's suppose if I example, I'm taking the same banking application, any application you can take, real-time application, let's suppose, or you might seeing like you might be seeing nowadays the famous applications like online shopping carts, right, where you can book your orders and all. Like you take the examples of if you take the examples of railway reservation system or online shopping carts or Gmail's kind of systems. So where you will have huge data, to be stored, right, and where the huge data should be sorted, searched, like this, right? So whenever you take, let's suppose, if you take a basic application like you might be if you do a online ticket reservation, railway ticket reservation, right? So you will be entering your usernames, passwords, then you will be entering sources and destinations. According to that sources and destinations, it should come up with the train details, and then you will book your if you want to book your train tickets and all, it should do searching of how many tickets are available and all, right? So like this, whenever you do these kind of common operations, if you take the very common operations, right? So what common operations you will have? Storing the data, retrieving the data, updating the data, right? So not only these things, we will come across searching is the most common operation. You will have search operation, right? Then you will have sorting of data. Generally we'll come across what? Sortings, searchings, arranging the data in a particular order for faster accessing. Right, if you take your hard disk, you will be arranging your data in such a way that when you want to search the things, when you want to sort the things, right? So you need to access the data very fastly, and it is you should access the things very fastly, as well as what? It is easy for you to maintain the data, right? So let's suppose when I'm storing my files into my hard disk, what I'm going to do here, I'm going to arrange them in a particular order so that in the future the data can be easily maintained for me. Easily I can search the data, as well as I can sort the data very easily, right? So here, if you want to do this kind of operations, if you want to do such kind of operations, right, each time, let's suppose I'm developing application, so each and every application, whenever you find the data, let's suppose I have an array, I'm having a group of students I'm taking in my class, right? Let's suppose I have an application where I'm trying to develop application where like student management system kind of application, where I want operations like when I enter a student roll number, your application should fetch the details of a student. Or I would like to sort the students in a particular order. I want to sort the students according to their names, or I would like to sort the students according to their averages. I want to sort the students according to their right. So roll numbers, or I don't want to see the duplicate names in my classroom. I want to have unique roll numbers in the classroom where I don't want to repeat the roll numbers. Right. Let's suppose if you take nowadays, we will be having Aadhaar card kind of system in our country. We'll be implementing. So what is this Aadhaar card kind of system, where the number should be unique, that number should be attached to a particular person, address, lots of things to be related, lots of data to be related to each and every. Now, if I enter a Aadhaar card, throughout these millions of population, if I enter a particular username, it should ID, it should fetch me the details of that particular person, and this number should not be duplicated, right? And if I want to do lots of this kind of technique, lots of these kind of operations, the basic operations, the most complex operations, searching the data, maintaining the first thing is maintaining the data in a particular order, then searching the data, then sorting the data according to your requirements and all. If your data is not properly maintained, right, the time takes to process the data or to identify some kind to identify the data and to process the data, they take what? Huge time, right? So for this, whenever you come across such kind of operations, right, so whatever you want to do, managing your data efficiently, if you want to manage your data efficiently for searching or sorting or maintaining, ordering, eliminate the duplicates, if you don't want to see duplicate data as rule numbers, but lots of things you can perform on the data. When you have the data, collection of data, and this data can be operated in many different ways, right? So let's suppose, as I told you, student management system. Now I want to sort the students according to their ages, roll numbers, names, right? Or I want to sort them by using their averages. I want to search a particular student. I want to search a group of students, right? So like this, if I don't manage my data efficiently, if I don't manage my data very efficiently, if I don't use my data very efficiently, the time taken for this will be what? More. And it is complex operations also. And very commonly, these are the very common operations which we perform on data, right? So whenever you are storing the data in your hard disk, that is the same thing. Whenever you want to read a file, if you don't know where you have stored and all, if you want to search it, right? If you arrange the data in such a way that if it is easy for you to search, or if it is easy for you to find out something, if it is easy for you to sort the things, or do whatever you want to do, if you are able to manage your data very efficient manner, then only you can process all these things. You can do all these operations. and very common operations whenever you have huge data. If one or two files, no problem. If you have huge number of files, right? So generally this is what here you can see here. Like let's suppose if I open my files here. Now if my data I have a lots of data inside this, like this you can see here. There is no proper arrangement of my data. It is very difficult to search something if I want to do. So there is some kind of sort by type or sort by date. If I arrange my data in a particular order so that it is easy for me to search. Lots of files, right? So like this so these are the very common operations whenever you have data, group of data, collection of data, right? So what common operations you will be having? Searching is the most important operation. Everywhere you will have search. Ordering the data means sorting the data according to your needs. If you don't want to have duplicate values, like this different operations will be performing on the group of data, right? And very regularly, very commonly performed operations. So if you have, let's suppose I am developing 10 different applications, and in 10 different applications I want to use such kind of operations, I want to perform such kind of operations, searching operations, sorting operations. Instead of writing 10 different times the same operations, right? So the Java framework, Java software has come up with a ready-made set of classes, right? So there is a ready-made set of classes are given for you which provides you such kind of all operations. Let's suppose as we have taken, I have a classroom where I have what 30 students, let's suppose, and each student I can treat it as one object. Now I want to perform lots of different operations on this group of objects, group of students. Like I want to arrange them according to names, numbers, ages, or I want to sort them according to something. I want to do lots of operations on this group of objects, right? And let's suppose I have a library management system where I have lots of books, and I want to do the same kind of operations on the same library management system. Everywhere you find this kind of operations. So instead of writing these kind of logics each and every time with each and every different application, because these are common operations we should be performing in different contexts. You can search a book in the same way you can search a student. In the same way you can search a strain, you can search a file in your hard disk, right? So instead of writing the same logic for multiple with the different applications, so Java provides us a set of classes and interfaces to perform all those common operations whatever you perform in each and every application, right? So this is a very simple here, very simple meaning here. You have a framework. What is the meaning of a framework here? In simple I can say a framework is nothing but a collection of classes and interfaces. Coming to Java, a framework is nothing but a collection of ready-made set of classes and interfaces which provides you which provides a developer with a ready-made set of classes and interfaces to develop their applications very easily. Instead of writing the code repeatedly with each and every application, right? So a framework is the software which provides you a set of ready-made reusable components, I can say, reusable things with each and every application instead of writing your code. So simply you can make use of these frameworks, and you can reuse the things which are there in the frameworks with the different applications to write your programs, to easily develop your applications, right? So for faster development of your application, instead of writing searching logic, let's suppose I have a searching logic. Now instead of writing my searching logic for a search student, for searching a book, for searching this and that, there is one common logic is written, and you can use this ready-made logic with your application, and it searches for you and it gives you. So instead of wasting your time, so there is a ready-made set of classes and interfaces are given for you which perform such kind of operations, and that framework we call as a framework. It is a software. A framework is a software kind of thing, I can say, which comes up with some ready-made set of implementations in the form of what class and interfaces, so that as a programmer you can use it wherever you require. Just use it instead of developing your own code for those kind of common operations. Nowadays you can see that nowadays whatever the latest software technologies you are getting, all are frameworks only. You might have heard about Hibernate framework, you might have heard about Spring framework, you might have heard about Struts framework. These are all what here. They are all ready-made solutions. They are all what? Ready-made solutions for repeatedly written codes. In such, each and every framework targets one area. So this collection framework, what is the meaning of collection framework? As I told you, this is a ready-made set of classes and interfaces which are given for you to write, right? So as a programmer, just you can use this framework to develop your applications instead of writing your own logics. Just you can use this framework to develop your applications. So this framework is generally, you can say, whenever you talk about some other programming languages, so whenever you talk about some other programming language, this framework is very much equal to, so I can say what? Java data structures programming. So in C and C++ you might find these data structures. The same thing here, Java data structures. Collection framework is nothing but the Java data structures program. But as a programmer, I am not going to write my own data structures which are already implemented for me. Just I am going to use them. You might have heard about right, algorithms like sorting algorithms, right? Bubble sort, right? This sort, like this. You have different sorting techniques you have, and you have different types of searching techniques you have, different types of arranging your data, trees, graphs, like this. Different data structure programs are given where they can ease searching, right? You have different searching techniques, you have different sorting techniques. So the best technique which you use to sort your data, you have bubble sort, merge sort. Different sorting techniques are there. So instead of writing your own techniques, instead of writing your own algorithms, right? So this frameworks provides you with what? The basic algorithms. Just you can use them whenever you require a sorting technique. This framework is already having that. Whenever you require a searching, this framework is already having it. So you can take it, you can use it in your application. Or if by using this framework, if you want to develop your own techniques, algorithms, you can do that. So this framework comes up with what? Ready-made set of algorithms, I can say, data structures, I can say, where these data structures you can simply use for for arranging the data. Like you might have seen like a data structures like stacks, queues, linked lists for arranging the data. You will be writing your own codes for arranging the data, right? So trees, graphs, such kind of things. You might be writing searching techniques. You might be writing sorting techniques. You might be writing eliminating the duplicates kind of things from a given group of data. So instead of writing your own logics, instead of developing your own algorithms for these common operations which you want to perform on group of data, so there is a ready-made set of framework. There is a framework which is given, which contains some ready-made set of class and interfaces, so that you can use these classes from this framework and to achieve your requirements. So if you want to search, if you want to sort, whatever you want to do, there is some ready-made set of classes are given instead of writing your own codes. That is nothing but what? Collections framework. So collection is nothing but what? Group of items. Whenever you have, if you have a single object, if you have a single student object, it is very easy to maintain. But if you have a, right, if I have group of student objects in my class, is it easy for me to maintain the data? No. If I have a single folder, yes, it is always easy for me to operate. If I have bunch of folders in my hard disk store and I want to maintain them easily, so that I can access them very faster, so that I can search my content very faster, then you will be arranging your data in such a order so that you can recollect it very fastly and you can access your data very fastly. So whenever you have single data, it's fine. But whenever you have a group of data, and if you want to operate on this group of data, it's not that much easy. As I told you, the example, right? So let's suppose you will be coming up with what? Elections, right? Now everybody should register for the voter ID card and all. Now what government should do here? They should check there is no duplicates exist. How they are going to identify out of these millions of people? If already duplicate identity cards, voter cards are already issued, then how they are going to identify these things? How they are going to manage all this complex data? There should be some kind of algorithms which picks, right, a particular algorithm which should be written so that it is going to identify the duplicate voter cards, or which should be identify duplicate lots of things, right? Let's suppose if you want to write the exams and all, central board exams and all, how many students will be appearing for board exams? Each student will be assigned with a hall ticket number and track the details of students, which student is writing a exam on what area and all. It's very complex to manage the huge data, right? So by writing each time, by writing your own algorithms, by developing your own algorithms and all. So whenever you have group of data and whenever you want to perform the operations on this group of data, it can be any operation on a group of data. And this framework helps you to perform the operations on the group of data very easily, whatever it might be the operation. It may be the arrangement of your data, it may be searching of your data, it may be sorting of your data, it may be finding the duplicates of your data, maintaining unique data, all these operations. Instead of writing your own logics for performing all these operations, so this framework provides you set of classes and interfaces which manages the data very efficiently for you. Right? It's the most important framework, right? So whenever you develop the applications, it's not working with simple data. You will be coming across what? Bundles of data. Right? If you take the example, any example you take, like you take a banking applications, how they are going to manage the account details of each and every person. How should they track, right? So taxpayers, how they should be out of these population, how government should identify which people should pay the taxes and all, how much tax should be paid, whether he paid or not. It's very complex to identify all these things, right? So this is what you have here, and these all classes which can perform you the operations, which performs you the operations on group of objects. Group of data is nothing but here objects, and all these classes are shifted with a one package. That package we call as what? Java.util package, or we call it as collections framework. And this framework, which is introduced in Java 1.2, it is not there in the initial versions. It is introduced in the Java 1.2, most useful framework for developing the applications. You might have understood what is the importance of this framework, because instead of writing your own logics for all these operations, whenever you have much data to be maintained, so instead of writing your own logics for maintaining this data, so you can take the help of this framework, and which takes care about managing your data instead of writing your own logics, right? That is the importance of this framework you have here. Like this, different frameworks are given for us, and different frameworks targets different environments. So this is a framework which is used for managing the data for you and performing the operations on group of objects, right? So that is what you have here, and it's not a new thing. Again, classes, interfaces, objects, very simple to work with this framework. As a programmer, very easy to work with this framework. There is no complexity, right? Because everything is developed for me. Just I want to use them. So you should know how to use these things. That's it. As a programmer, you should know how to use this framework in the classes. That's it. Nothing much we are going to do here. Very easy to work with this, right? So this framework is shifted in the form of as we discussed, right? Now let us try to see this framework first of all. Again, I'm trying to open the API so that we can still more clearly understand what is this framework. Are you following me what I'm trying to explain here? Yes or no? Hello. Right, the package name is java.util, and this is what you have here. Right, so it is util package. So what it is going to do here, contains collection framework. Right, so what is the meaning of collection framework? Up to now we try to understand some setup, ready-made setup class and interfaces to maintain the data efficiently instead of writing your own logics. Apart from this, it contains some legacy classes and event models. We try to understand what is the meaning of event models. Right, so very common again, date and times, working with dates and times. Whatever the class, there are some classes are there, predefined classes in the Java to work with date and times. Those classes also there inside this package, util package. Right, internationalization, one more important class concept nowadays, which is hugely used in developing web applications. I-18N, we call it as what? I-18N, internationalization. So all these classes and some miscellaneous utility classes like string tokenizer, random number generation, like lots of classes are given as part of this framework, which are used very hugely in commonly used classes, I can say, very commonly used classes in each and every application. So dates and times, you have some predefined classes to work with dates and times, right? To work with complex data, to develop internationalized applications. Like this, you have separate set of classes here, right? So this is what this collection framework is going to do for you, right? So here again, it's not, this is a package, and this package is divided into different this package is given for us in a particular having its own hierarchy of class and interfaces, right? So whenever you find any framework, generally a framework starts with a root interface. Whenever you come across a framework, generally all frameworks starts with a framework interfaces. So there is one root interface. That interface called as what? Collection. It is what? An interface. There is one root interface in this. What is that? Collection. One more root interface is there, that is called as map. So what is the meaning of maps and collections? We try to understand. Alright. So there are two root interfaces, I can say, for this framework. So we try to understand what these uh, root interfaces are for and how they be, what is the meaning of these two root interfaces. Now we try to understand first interface called as collection interface. So what does it mean and why it is, what it is going to do for you and all. Again, simple object orientation, interfaces, right? So we'll see here one root interface is given. So this framework is divided into multiple classes. It is used for different things, right? And it provides us set of classes and interfaces. And there are two root interfaces. The one is collection, this is the one, and the second one is map. The second one is what? Map. So like this, we have two root interfaces. Now we see what are these root interfaces can do for you. Just let's see what is collection here, right? So what is a collection here? It is an interface. Collection is an interface. So what is this? Root interface in collections hierarchy. There are some set of hierarchy of classes are given for us, right? And this is the root for all these classes, base, right? So very important here. See this? A collection represents what? A collection is nothing but a group of objects. A collection is nothing but a group of objects. So already we have come across such kind of group, right? What is it? Arrays. Arrays is also not a different thing. It is a group. And whenever you have a group of data, and you will come across what? Lots of different operations to perform on the group of data, as we discussed previously. All those operations can be performed on what? A group of data. But there are some drawbacks all there going with arrays and all. To overcome those drawbacks or to support for easily maintaining the data, right, and all, the collections framework is given for us. It is entirely different, right? So what is this? A collection. What is the meaning of a collection? Group of objects. When you talk about group of objects here, when we talk about group of objects, a group of objects contains what? Different properties, different set of properties, right? A group, and on a group of data, you can perform lot of variety of operations as we discussed, right? So when I have a group of students in my class, I can do whatever the operations I want to do, I can do, like searching, sorting, eliminating the duplicate rule numbers and all, right? So basically this is a, so collection framework is nothing but what? A group of objects. A collection is nothing but a group of objects, and whenever you are collecting the data, right? So because in Java programming language, whenever we say data is nothing but what? Object. And whenever you have a single object, it's fine, but whenever you have a group of objects to be maintained, and if I want to perform the operations on group of objects, it is very complex. So there are some ready-made set of, right? There are some ready-made set of classes are given for us, and these classes are going to help us to do all those operations. There is nothing but a collection, right? So what is a collection here? A collection is represents a group of objects, and whatever the operations you want to perform on a group of objects, you can perform on these things. A group of objects, that is nothing but a collection, right? Now we talk about we describe something related to whenever you try to group the data, what type of requirements you have here. Whenever you try to group the data, generally what type of things you will come across? Right? So according to the different situations, you'll be coming across what? Different types of grouping the data. Let's suppose if I want to collect let's suppose, if I want to collect or if I want to give a card kind of thing, numbers. Now when I talk about the numbers, generally what we'll find here, I want to have group of numbers, student roll numbers and all, phone numbers, group of phone numbers. Generally we'll find with what? We'll come across what? You don't want to see, whenever you talk about phone numbers and all, you don't want to see what? Duplicates. Or it is possible to have what? Duplicates also, but not in phone numbers case, in different case. Names. So whenever I talk about group of data, a group of data can contain what? A group of data can contain duplicates. I can have what? It's quite natural to have what? Duplicates of data, or I don't want to have what? Duplicates also. That's according to your requirement. Let's suppose I want to assign rule numbers, or I want to have a telephone directory kind of thing. If you take a telephone directory kind of thing, you have a huge data with associated with what? Phone numbers, where phone numbers will not be duplicates, but the names definitely can be duplicated. That require, so these things will be depends on the data, how you want to collect the data. Let's suppose if I collect students, names of the students can be duplicates, but roll numbers cannot be duplicates, right? So whenever you collect the data, obviously that's your requirement dependence, whether you want to have duplicates in the data, or whether you don't want to have the duplicates of data, right? Or whenever you collect the data, you may come across what? Still what you can come across? Duplicates, no duplicates, right? Still you can come across sorting, data itself. While I'm collecting the data itself, I want to sort them or unsorted, right? And I can have what? Ordered, unordered. Ordered means what? Ordered data or unordered data, right? Now I can have my data can be ordered indexed or unindexed data like arrays, right? So you can still have what? Duplicates, no duplicates, sorted, not sorted, ordered data, unordered data, indexed or unindexed. Still what you can come across, right? Because we are talking about objects, right? There may be a null objects or no nulls, right? No null values. Still, still what operations, what things you can find whenever you are collecting different types of data, right? Very important. The data can be homogeneous. Homogeneous means what? Same type, or it can be heterogeneous. Different type of data can be combined together. No problem. You can also have heterogeneous, most important, right? Still homogeneous or heterogeneous. Similar type of data you can group, or you can group what? Different types of data together. Still what you can come across. Right? So these many things will be having actually. Still more you can find. Still more you can find here. Right? So these many things you can come across. Generally, whenever you are grouping the things here, so lots of things you can have on the data. While collecting itself, I want them to be ordered, sorted, indexed, or I want to have only certain group of objects, or I can have what different types of objects together. I don't want to see the duplicates. I want to see the duplicates. Different things you will come across, right? So this is what here a collection means. Whenever you are collecting, it is not simple. Whenever you are collecting different things together, you will always come across these kind of things, right? So a collection allows some can have duplicates, some cannot have no duplicates. Some are ordered, some are not ordered, right? Some other like this you will have different things. Then why can't I use arrays for collecting the things here? Why can't I use collections? Why can't I use arrays for such kind of collecting the data here? Arrays also doing the same thing here, right? So there are but slight limitations you have on arrays. The biggest problem with arrays is their size is limited. They have limitation on the size. You cannot go beyond the size. Once the size is declared, you cannot go beyond the size. There is one more important point. If I don't know how much data first I want to collect, that is the biggest problem. If I am trying to collect the data, but I don't know how much data is there, then right? So that is the way, that is the biggest advantage you have here. So what all collections can do for you? So there are different collections are there. So collection is nothing but what? Collecting the data. And you can collect the data in multiple different ways. That is the first thing. I am going to collect the data and I am going to perform the group of operations on a data, and while collecting the data I am going to do, that's my requirement. I want to, whether I want to collect the data while collecting itself, I don't want duplicates, or my data should be arranged in a particular order, right? So like this you can do lots of operations while you collect, but the basic thing is, the most important thing is, if I don't know how much data I am going to collect, right? That is where the beauty of this collections framework comes into picture. All collections, whatever the way I am going to collect the data, each and every collection, if you don't know the size of the data also, so they can automatically, they can increase the size and they can decrease the size, grow and automatically shrink. So what does it mean here? What I'm explaining, what is the meaning of automatically grow and shrink? Right? Nothing is there. Very simple here. Very simple. So what does it mean here is, A collection is, in simple, if I more technically discuss here, a collection is an object. First of all, a collection is a Java object which is going to collect different types of objects. A collection is what? A object which is going to collect different types of objects. That's it. So I am going to collect different types of data. I am going to group all these objects into one object. I am going to collect different objects, and I am going to make all these objects as one object. So this is nothing but what? A collection. It's nothing but what? A collection. Set of rule numbers, right? List of names, set of phone numbers. So I am going to collect the data and I am going to group them into one object. This object is called as what? A collection object. And what about this automatically grows and the strings? So whatever the collection object I am talking about, so there is no limit for this size for this object. So if you want to have 100 objects, collection of 100 objects, so you can add all these objects into one collection object. If you want to have 1000 objects, yes, you can add. If you want to have 1 lakh objects, you can add into one collection. It is not possible with arrays. Arrays is also a collection. It is, they are not different. There is already there such kind of collections, but they are limited in the like what sizes. Here there is no size. Now how much data I want to collect? You can easily collect all the data together in the form of, and you can store all this data into one object. You can collect the different data and you can store all this data into one object, and this object can be used to perform your operations on what? These objects. So a collection is not a different thing. A collection is what? A collection is a object. A collection is a Java object which represents what? Group of other objects. It is a Java object which represents group of other objects, and whenever you collect your objects by using this collection, you can easily perform the operations, whatever the operations you want to perform, right? So a collection object may allow to add duplicate objects, or it may not allow you to add duplicate objects. Some collections can arrange your objects in sorting, or some may not arrange your objects in sorting. Some maintain some order, some doesn't maintain some ordering. So such kind of different collections we have. That depends on your requirement, which collection you should take. You will understand here what is the meaning of this. So this is what here. So a collection is a object. First thing is, a collection is a object only. And this collection object is used to group some other Java objects inside it. And whenever you group all the objects together, and it is easy for you to perform all the operations on the group of objects. And without bothering of how many objects you are going to collect and how many objects you are going to group together, the size of this collection will be automatically grows and shrinks. That is the beauty you have with this collection. It's not a different thing. It is a object only, and these objects contains all these behaviors. What are the behaviors? What properties you have with a collection objects? The first thing is, a collection is an object which can allow you, a collection is a group of Java objects. That is the first point. A collection is a Java object which contains group of Java objects, group of other objects, and the group of objects can be heterogeneous or homogeneous. You cannot say. They may be heterogeneous, they may not be heterogeneous, and the size of this object can automatically increase or decrease according to your requirement, right? So that collection can have, it may allow you to have duplicates, or it may allow you to have no duplicates. They may be ordered, sorted or not sorted, collection of objects. They may be ordered or not ordered. They may be indexed or unindexed. There may be null values or there may be no null values. So like this. That's requirement dependent. So there are different types of collections. According to your requirement, you need to choose one collection. Which collection I want to use. Right? So this entire framework, whatever we are talking about, collection framework, this entire framework is divided, we can divide into different things here. First we will talk about interfaces. It contains some set of interfaces. The second thing is it contains some set of algorithms, right? So as we are discussing predefined implemented algorithms, it contains some set of algorithms, and it contains some set of what implemented classes. We are not going to write anything, just we are going to take the help of this, and different algorithms will be used for different purposes, and they are already implemented for us. All algorithms are implemented for us, just we need to use the appropriate algorithm according to your need. If you don't want to have duplicates, now pick a class, pick a implementation which has an algorithm, right? And that algorithm will not allow you to add the duplicates together. If you want to sort the elements, yes, pick the algorithm class which has an algorithm, right, of sorting the elements, right? So this is what a collection interface majorly contains. What these things: set of interfaces and algorithms and the implementations. And as a programmer, just will be using these implementations, and each and every implementation will have implemented based on one kind of algorithm. Each and every implementation will have what? One kind of algorithm. Some algorithms allows you duplicate, some algorithms will not allow you duplicate, some algorithms sorts the objects, group of objects, some algorithms will not sort, some algorithms orders your objects, some algorithms will not orders your objects. So like this you have different algorithms. According to your need, you need to choose one implementation, which type of implementation you want to have. According to that, you can arrange your data. That is what is this collection. So it is not simple. It is not simple here. Everywhere you come across this, it's not that much simple. So collecting the objects is not simple. You can come across lots of wide variety of combinations of the data. And whenever you have such kind of complex data, it is very difficult to maintain. So that to overcome all these things, to overcome all these problems, so Java people has provided us some ready-made set of classes and interfaces. So by using them, with the help of them, instead of writing your own algorithms and classes, you can develop your applications, right? So this is what a collection means. A collection can have all these properties, and it is what a interface. A collection is an interface, and which is given for us in the Java. So it is an interface. What is a collection? It is an interface, and by using which you can write your. There are different types of collections. What I can say here, these are the different ways you can collect the data. So basically, there are three different ways. I can say three different ways you can collect the data. There are three different things are given for us for collecting the group of objects, right? Again, these three different are again three different collections, I can say. Again, all are interfaces, right? The first interface we can say as what? List, right? The second interface we call as what? Set. And the third one is the one new one which is introduced in the Java, that is called as what? Queue. All represents group of objects only. Queues. All represents what? Whether it is a collection of type list, or if it is of type set, or if it is of type queue, all represents group of data only. Right? Simple inheritance inside this. Right? What is the meaning of this? Inheritance. So what does it mean here? If you apply the inheritance rule to this, the collection is said as what? Most generalized form, and these three bottom layer is said as what? This bottom layer is said as what? Specialized forms of what? Collection. So these three are, I can say what? Specialized collections. This is a most generalized form of a collection. Most generalized form means what? The objects can have duplicates, no duplicates. No specific behaviors you can see here. No specific implementations. It talks about more general things of what? Group of data. And there are some specific implementations for this group of data. There are some specific implementations you have for this group of data. That means what? These are the three specific things for a collection. What are the three specific things? So I can say in simple, I can say in theoretically, you can collect the group of data in the form of what? List, or you can collect in the form of sets, or you can collect in the form of queues. These are three different specialized forms of collections. Each has their own specific way of collecting the objects. Each has its own specific way of what? Collecting the objects. All are interfaces again, right? So these are not implementations, these are interfaces. So understanding this interface is very important. All are interfaces. Here whatever I am discussing, all are interfaces. So what is the meaning of list interface? What it is going to do? How it is going to collect the objects? So what I can say, list is a collection. What is list? List is a collection. So list is a more specific way of collecting the objects. So as we discussed, collection is a group of objects and list is a more specific way of collecting the objects. So what is the meaning of this list? How it is going to collect? It has its own specific behaviors, right? So here you have list. So what is this list is going to do here? What is a list? It is specific. What is its specialty? It is an ordered. What is this? Ordered. So how I am going to collect the objects as a programmer? How I am going to collect the objects? And if after collecting these objects, how I am going to add these objects to a list? This list is going to maintain the same order. An ordered collection. List is an ordered collection. Right? So it is an ordered. So as we discussed, a collection may be ordered or unordered. So coming to specific, so it is going to maintain the objects in the order how you collect it. If you collect the first object, it will be always there in the first position. If the second object will be occupies the second position always. Third object will occupy third position always. It is ordered. A list is a ordered collection and allows you duplicates. It is a duplicate. Ordered allows you duplicates. So if you want to have duplicate objects inside your collection, then the preferred collection is what? List. Right? And it allows you more null values. Yes, it allows you null values and more number of null values, right? And still we have described no sorting. There is no sorting for your elements, because how I am collecting the objects, I don't know how I am going to get the data from different areas. In the same way it is going to store the data. So it is not going to sort, and the most important, it is indexed. Indexed collection. Indexed collection means what? Same like arrays. A list is almost similar to what? Arrays. Indexes. It is an indexed collection. Right? And which allows you heterogeneous. That is the difference you have between arrays and this one, list. So list almost similar to arrays. The difference is arrays will not allow you. Arrays will not allow you what? Heterogeneous data, whereas this list allows you heterogeneous data. And this list automatically it increases the size and automatically it decreases the size. Not only this, whenever you talk about arrays, always whatever the operations you should perform on the arrays, always the operation should be performed by using indexes. If you don't know the index of an array, if you don't know the index of the data, you cannot access it. You must know the indexes, and all operations are but index based. But coming to the list type of collection, it is almost similar to arrays, but no need of remembering the indexes. Though it is indexed, but you can perform the operations without using indexes also. You will see all these things, but writing one simple program need to be written so that you will understand what does it mean. Right? So it is specific. So what is this? This is a more generalized interface, and this is a specific interface which has these specific operations. Now whenever you are grouping the data, and if you want to have the data should be grouped with all these functionalities, then it is better to go with what? List type of collection. Example, you can take Example of list of numbers, list of what? Names. Names in the classroom definitely will have what? Duplicates will find. And most commonly used actually this list is list of items, not list of items actually. Right? So this is where you come across what? List. Are you following me? What I'm trying to explain here. This is more theory. It's completely theory. Coming to usage, very easily you can use, but lots of theory will be there inside this collections framework. Are you able to follow what I'm trying to explain here? Take the examples, whatever the examples I have given. Right? So whatever the examples I have given, voter ID card system or Aadhaar card system or railway reservation system, how much data will be there? Right? Nowadays you'll be seeing these kind of websites where you will find you can buy the products. How much data they should maintain? Right? If you take the basic example of red bus dot something, bus booking, redbus.in, how they are going to provide you filtering. You can search by using lots of things, prices. You can search the products by using price, seat numbers, AC, non-AC, this, that. Oh, how it is it easy to maintain all this data? It's not that much easy to maintain. Right? That is where this collections framework is given for us, instead of writing your own logics. Right? So this is what here you have list. Don't think of, like, whenever you have complex data group, it's always difficult to perform the operations on group. If you have single units, it is easy to use these things, but when you have the data group, then it's very difficult. Right? So this is where you come across list. It is an interface. Again, it is a child interface for what? Collection. The child interface for what? Collection. List extends. Interface to interface, we use a keyword called as what? Extends. An ordered collection. So how we are going to collect the objects? In the same order they will be maintained. Right? So here the user, whoever collecting the data, the user will have what? Precise control over the list, because it is going to maintain the same order. How we are trying to collect, it is going to maintain the same order, and by default it is going to assign some indexes to your data in the same way arrays. How the arrays are going to, how whenever you try to store the data inside array, how it is going to give the indexes. By default your data is also given indexes. Right? Whenever you have indexes, it is very easy to what? Search. Right? It is very easy to search content, because directly you can jump to that index position and you can get the data. If you know the index, you can directly jump to that index and to get the data. If you don't know the index, you need to go through each and every page. Right? Like this you have. Right? So like this you have here, this is a list, specialized form of what? Collection. It is a specialized form of collection. Right? So whatever the operations you want to perform, you can perform. Add the elements, remove the elements, comparing the elements, getting the elements, iterating, all. Right? So lots of things you can do here. Right? So this is what a list. Set, what does a set mean here? Again the same thing. Set is a collection, list is a collection, set is a collection. But what is the difference? What is the difference between these two? The way the objects are collected is the difference. They are 100%. They are quite different way of collecting the objects. So one allows you ordering, the one does not allow you any ordering. It is unordered. List means what? It is unordered. If you are trying to collect the objects in one way, it is going to maintain the objects in some other format. It is unordered. You cannot guarantee the order of your elements inside it. Second is what? Right? Not indexed. The first important thing is what? It will not allow you duplicates. That is the first important thing. No duplicates. Unique. We want to have your data uniquely. Set of roll numbers, set of natural numbers, set of mobile numbers. You don't want your data to be duplicated. While I am collecting the data, while I am grouping the data, I don't want to see any duplicates. My data should be unique. Then go for set. That is where this is. List is definitely it is going to allow you duplicates. Set never allows you duplicates. So whenever you say set, unique data you will find always. You will find always what? A unique data. Right? Like this you have set. It will not maintain any ordering, but in the same way it is not going to allow any duplicates for you. Right? So not indexed. There is no indexing. So it will not use any index positions. So it is difficult to search the things. If you don't have indexes, it is difficult to search the things. Right? So still sometimes it maintains the sorting and sometimes it will not maintain the sorting. Allows you heterogeneous. Yes, it is also going to allow you heterogeneous. Right? Null values. Some allows you null values, but only one. You can take only one null value because no duplicates are. So you cannot have duplicate null values. Only one null value, right? You can take like this, only one null value like this. So these are the two different ways I can say. You can see here, you can understand the differences here. Almost quite opposite. Ordered, unordered. Duplicates, no duplicates. Most important one. If you want to have your data to be duplicated, you go with list. If you want to have no duplicates, you go with what? Sets. No sorting. If you want to sort, it may sort, it may not sort, but both allows you heterogeneous. Sometimes this set will not allow you heterogeneous, right? And it allows you null values, only one, but it allows you multiple. So like this you have here. So this is no duplicates, this is duplicates. If you want to order, you should go for list. If you want to have unordered, you can go for what? Set. Q is the same thing. It follows a simple algorithm. It is 1.5 addition to the Java. 1.5 addition to the Java Q interface. Right? So this is what you have here. Not going to discuss much about queues. It is only used to, I can say what, simply for storage purpose. Queues are used for storage purpose. They are not that much faster in accessing the data. They are only for storage purpose. Right? Like this you have here. So these are the three different types of collections I can say. So I can say in simple, there are three different ways I can group the objects. One way is list way, the second way is set way, the other way is queue. These are three different ways I can collect the objects. Right? So this is what you have here. Very simple. Are you following me? So that's your requirement dependent. Whatever the data you are collecting, if you don't want to see duplicates, you need to choose set. If you want to see the duplicates, you need to go for what? List. Like this. Right? So like this you have these things. Okay, are you following me what I'm trying to say here? Just one or two programs are required compulsory. Without this you cannot, it is more theory. It is completely theory. because these are all very regularly performed operations. Okay, are you following me? Shall we continue then? Okay, fine then. Right. So this is what you have here. So you can see the set. Again, it is an interface, a collection that contains no duplicates. A set is a collection which contains no duplicates. Right? No pairs. Right? Most one null value. Interface models mathematical set it's most similar to what set in the maths. Set of elements. Right? So this is what you have here. So this is absolutely, as a programmer, this is your requirement which one should be used, whether you want to go for list or whether you want to go for set. Right? Set of collections. Now what operations generally we perform whenever you are going to group the things? What general operations you perform here? If you see this, so this collection interface defines some set of methods. Generally, most common operations, what we do, right? Create the data, right? Read the data, update, delete, and whenever you have a group of objects, check whether search the data, whether it is there or not. So like this, we will perform different operations, right? So this collection interface has set of methods. Very important, these methods are, right? So what is this method is going to do here? As I told you, a collection is an object. What is a collection? Collection is an object. So a big object, inside this you are going to add what? Some other objects inside this. Now how you want to collect the objects together? How you want to collect the objects? There is one method is given. Very important, see this. This is inheritance here. What is this add method? What it is going to do here? Add method is going to add the group of things together, which is used to add the group of objects together. Right? So first of all, I am going to create a one big object, collection object, and into this collection object, if I want to store my object, I have a method called as what? Add. Like this, you can add what? A number of objects to this collection object. Now my question is, where is this method? This add method is inside collection. Can I use this method inside list, as well as can I use this method inside set? Is this method will be present in list as well as set? Add method is from collection. Is this method will be there inside list or set? Whatever the methods you have inside a collection, all these methods will be there inside what? List, set and queue. Each and every method will be there inside all these child classes. Right? So add method I have inside what? Collection. That means that method will be present inside what? List as well as what? Set. So what add method is going to do here? Add method is used to add the objects together to a collection. But this add method behavior, just I am explaining here, this add method behavior is different. What is the meaning of add method behavior is different here? When I am trying to add the elements, to a list, what it is going to do here? This add method allows me what? Duplicates. Adding. When I am trying to add the objects together, we use the add method. So when I add this add method with a list, when I use this add method with a list type of collection, what is that add method is going to do? That is going to arrange me the objects in a particular order. It is going to allow me the duplicates. It is going to index the objects here, but when I use the same add method with a set, it performs quite differently. That is the meaning of interface. Interfaces means what? One definition, multiple implementations that we see when we discuss interfaces. The same add method has different implementations. Right? That is the beauty of this. So remembering the methods from this collection is very important. Add. We want to add the objects together. We have a what? Add method. Because collection is an object. What is the meaning of add all? Because a collection is an object. Right? To one collection, if you want to add one other collection, you want to add one collection to other collection. So this is add all. Clear means what it is going to do? Remove every element from what? Group. Contains for searching. See the operations. Adding the objects together, removing the objects from, searching the objects, right? See whatever the basic operations we perform, all you can see here. Equals. What is the meaning of equals here? It is used for comparing. Equals is for comparing. Is empty to check whether the data is there or not. Right? So what is iterator mean? What is iterator is going to do? Iterator is for extracting the data from the collection. You want to extract your data. It is going to extract the data. Remove a particular object. Remove all means what? From group of objects from a collection. Right? Size to check how much size is there. What operations we require? Whenever you have group of data, whatever the operations are required, all are there. Right? So adding the data together, clearing an entire, searching the data, comparing the data, right? Retrieving the data, removing a particular object. Like this you have all operations. So these are all methods from collection, and each and every method will be there what? Inside list. Whatever the methods you see in a collection interface, all methods will be there inside what? Lists, sets and all. So the way I add, so what is the meaning of this? As a programmer point of view, if you think from the programmer point of view, how I am going to add the data to a list is the same way I am going to add the data to what? To a set by using the same method. How I am going to add the data to a list? In the same way I am going to add the data to a set. But internally how the data will be arranged for me will be different, and which is taken care by the implementation. So it is already implemented there for me. It is going to take care here. As a programmer point of view, if you think how I am going to add the data to a list is the same way I am going to add the data to a set. But depends on the collection, what collection you are taking, whether you are taking a list or set, your data arrangement will be changes. The properties of the data will be changes. Right? So if you want to see, let me write one simple example here. Let me write one simple example so that you can understand this, what I am trying to explain. Right? So here, just I would like to write one simple Java program. What does it mean? We try to understand here. So collection. This program we will be understanding. Come on, just I would like to clear something here. Public class collection example. So what is the meaning of this? I would like to group different data together. It works purely on the group of objects only. You cannot add primitive data to this. Works on purely objects. So there is a list type of collection. It's not a class. Right? There is a class which is already given for us. Let's suppose I am going to take that class array list. Some AL is equals to what? New array list. Right? So to this I am going to add AL dot add. Add method I can use because array list is a collection. It is a list type of collection. What is its type? It is the list type of collection. It is a class, and which is going to use array list object is going to can be used to collect the objects. Now I'm going to do what here? ABC. Let's suppose I'm adding one object, string object to this. and I'm going to add one more string object to this. ABC, same. Both are same. Right, let me save my program with the collection example data Java. So let me compile and execute my program. Java C example.java. Let me run my program. I need to import the package because this class all are from a package called as java.util.star. Right? This is fine, compile. Now Java example. Right, so it is fine executed, but it's not showing the data because I did not printed it. Let me print it. System.out. Print enough. What data I have in my collection? Just I would like to see AL is my group of data. Just I am printing the group of data there. See, you have ABC and ABC. What is the type of collection here? It is a list. What it is going to do here? It is going to arrange your data and it will allow you the data what? Duplicates. Let's suppose XYZ. ABC XYZ in the same, it is ordered. List is the ordered collection. See, in the same order it is storing the data. Just so this add method is also there for what? This add method is also there with some other collections also because it is from collection interface. I can use it with what? List type of collections as well. I can use it with set type of collections. I'm going to change this from set. As a programmer point of view, nothing is there. It is simple. Just I have changed the collection object. Now what is going to do for me? Add method will be there. Yes, add method is also there in the set. See here. Did you see the difference here? A set will not allow you any duplicates. You have only one ABC. I have added multiple ABCs, but you can see only one ABC in your collection. Add method, see here, when I have taken the list type of collection, this add method is behaving differently. When I have taken this set type of collection, this add method is behaving differently. And all these methods can be used on each and every collection. All these methods, whatever the methods you have in the collection interface, all these methods can be used on each and every collection. But their behavior changes, their implementation changes with what? This type of collection to collection. And that is the meaning of these properties. These properties, whatever I have given, these things you will be seeing in the programming. Right, this is the example, right? So here see this, the two examples, whatever you see, when I have a list, it is doing different way, ordering and the data arrangement will be different way. When I have set, the data arrangement will be different way. Array list. So as a programmer, just I am not going to do because all are implemented for me. I am using them. This is the meaning of framework. Now I can see if I compile and execute it. Compile and execute. See the difference between both. Just one statement change in my class. I just changed my collection type from set to list, and you can see the collection of data, how it is going to collect. That is the meaning of what? Predefined. I am not going to write my own data. As a programmer, if I want to eliminate the duplicates, I need to write my code, then I should use that logic to eliminate the objects, but no need. It is already developed for me and I am using it. Did you understand? This is what here. Did you understand what is the meaning of sets and lists? As a programmer, I am not going to write anything. No technique I am going to use. All these type of techniques implemented for me, just I'm going to use according to my requirement. That's it. So see, when I'm trying to collect the data by using array lists, duplicates. This is what I described here. Ordered duplicates. And when I try to do the collection by using the sets, it is not allowing me to have what? Duplicates. So as a programmer, nothing we are going to do here. So all these things are implemented for you. So we need to talk about these implementations. We have discussed something related to what? These interfaces. Right? So these are the major interfaces, 1, 2, 3. Right? And coming to sets, there are different types of sets. Again, you can collect the data in the sets in different way. Whenever you have no duplicates, and you can collect still more way you can collect this data. Sorted set. One more is there. What is that? Sorted set. What is the meaning of sorted set? While collecting the data itself, it is going to arrange your data in a sorting order. If you want your data to be ordered in a particular sorting order, no need to write your own logic. This is going to take care about arranging the data in a sorting order. Sorted set. Oh, it's not sorted sort. It is sorted set. Wrong. What is this? Sorted set. Right? So like this. As a programmer, simple, but huge theory and very hugely used also. To reduce the burden on such kind of logics, implementing such kind of logic, already they are implemented for you. Just we are going to use them, that's it. That is the meaning of a framework. Right? So today we discussed something related to this interfaces. Tomorrow we'll see about these algorithms, what algorithm is, how many algorithms are implemented in Java, and what classes are there for us. So I'm not going to use anything, just I'm going to make use of classes which are, so here I have used two classes, previous example. I have used a array list class and I have used a hash set class. So depends on your requirement, you need to pick the one class and you need to use it, and it is going to do all tasks for you, whatever the required tasks are there. It is going to automatically perform all those tasks for you. Eliminating the duplicates, yes, go for a class which is helps you to eliminate the duplicates. If you want to arrange the data in a sorting order, go for a class which is going to arrange your data in a sorting order. If you want indexes for your data, choose a class which is going to add your data by using indexes. Just you need to choose the data. Right? So tomorrow we'll discuss about